Hello everyone, I'm Barak. I just wanted to quickly introduce and show you how to work with TD-Runway, which is a new TouchDesigner component for interfacing with Runway. If you've never used Runway before, it's a machine learning model running environment that encapsulates a lot of the pain of getting models to run either through TensorFlow or Torch or PyTorch, and just lets you test different kinds of inputs, different kinds of outputs with different models. It has generative GAN models. It has body recognition, face recognition, object detection, a bunch of different things. It's really cool. The number of models that they support has been growing very, very quickly. I originally released a small component that allows interfacing with PostNet specifically, but since the interface has changed and people have been having issues, just decided to rewrite this as a more general purpose TD-Runway, which allows interfacing with a lot of different identification models or classification recognition. This will not be supporting image generation or sending images for things like style transfer back and forth, because that requires base64. That's the only interface that's supported right now. So that's a bad idea, in my opinion, to send images in base64 back and forth. So it's mostly for inference of either body or object recognition. But it allows a very quick prototyping in TouchDesigner using either your webcam or streaming tops into Runway. I'll show you how to do that later on. So to get that, you just go on GitHub to TD-Runway, download the talks. There's also the examples file, which is this file, which I'll show you how to use. I'll introduce TD-Runway through the examples. Yeah, so there are some idiosyncrasies of working with Runway for networking, which I'll describe as we go, but the main interface of working with it is either through Socket.io, which is a wrapper around WebSockets, or with OSC, which is a UDP-based transport. In either case, unfortunately, Runway sends JSON, which requires parsing, so it's a little bit slow. I wouldn't use this in prime time. I will use this as an experiment to find the model that you like and works best between all of the different options, and then maybe invest some time in implementing either a TensorFlow or a Torch equivalent to get better performance. But it's definitely an easy way to start experimenting. So the models that are supported right now, so first of all, transports are OSC and Socket.io. As you can see here, you can choose which one. You'll have to match the port. I'll show you where to find that. And the models. We have PostNet and PostNet coordinates, which are two different models that parse the same input, PostNet data, which is either single or multi-pose 2D body detection, and spit out the body positions. Face landmarks, which is the more dense face-only recognition. Yolo v4 for object detection, as well as Coco SSD. And DenseCap, which is a richer captioning of object detection. So you could say things like man with black hat, white coffee cup, rather than just saying person or cup. So it's a bit more interesting to work with. You basically choose a model that matches whatever model you're running inside of Runway, and it will parse. That's the data that it will expect through either OSC and Socket.io, and just parse it automatically based on your selection. So just make sure that the model matches whatever you have running. So we'll start with PostNet, and I will just PostNet, as you can see here, gives you a few face landmarks, not many, and mostly just body positions of one or more people. And to get that to run, you load PostNet from the browse models. You can search for PostNet. And one second, PostNet. And I already have that loaded in my workspace. So it doesn't show, but it could add it to workspace. These are the workspaces. And here inside PostNet, it's actually running. How is it running? It's not running. Run locally. Let's see. I need to capture the camera. So it will say that it's starting. Camera. And all right. So as you can see, it will find the body landmarks, and it works much better when you're further away from the camera. And it's a bit slow because I'm running it into TouchDesigner and doing a screen recording. You should get much better performance, but for the sake of demonstration. So you can see it gives you body landmarks. It will actually even give you off-screen landmarks with offshoot X and Y coordinates that are past 0 or 1. So anyway, we get these points on the face, we get the body points, and now we want to get that into TouchDesigner. So if we go into the network tab, you'll see that we have a choice of protocol. If we work with OSC, just notice the ports in the computer that you're getting the data from if you are running inference on a separate computer. So for OSC, it's always 57100. That might be configurable in the future. Just make sure that the port matches here. For Socket.io, again, 3000 most of the time. Sorry, all of the time. And just make sure that that matches. So I only have one address and one port listed, so just make sure that you change that depending on the transport. So we're going to be using Socket.io, and I'll change this to 3000. Now, another introduction to some of the idiosyncrasies of working with Runway. The server, the networking server, only starts when you run the model. So you need to run the model, wait until you see the stop, so it actually started running, because you can see that it says here, the Socket.io server will only be available when the model is running. So the actual networking server that they have, I guess, built into Runway only starts when the model is running, and only then can you ping to sort of register your client with Runway. So if you just open Runway and TouchDesigner, which you might have done if you end up on this video, you'll see that you're not getting any data until you click the connect button here inside TD-Runway, which is one of the main reasons I built this thing, to avoid having to deal with the handshakes for every single model. You have to tell Runway that you're listening, otherwise it's not going to send anything for both Socket.io and OSC. So you have to press this connect button every time you run a model. So when you stop the model and run it again, you again have to press connect. So you only have to do it once as long as the model is running, but you have to do it. So you can see now I'm inside TD-Runway, and I will connect the data into the PostNet DAT here, because that is the data I'm expecting to receive. I'll disconnect this. I left 3 examples here: PostNet, face landmarks, and all of the classifiers, because all of the classifiers end up being mapped to exactly the same format. So inside TD-Runway, I'll say that we're expecting PostNet coordinates over Socket.io, and connect. And I will zoom in a little bit. And you'll see these numbers moving very, very slowly. Again, a lot of stuff expecting from my MacBook, so we're running at pretty low frames per second, but without the screen recording, this is usually hitting around 50, but also because Runway is running locally on the computer, models that run remotely perform a lot better. But clearly, this is more for experimentation. So the data that you get from PostNet will be all of the landmarks with no labels, because there can be one or more people detected, which is only the case with PostNet. So you can see nose, left eye, right eye, blah, 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 and this will be XY. Now, if there's more people, you will have XY, 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 in which case you will probably want to use something like a shuffle chop when you convert the data to be able to sequence them. You can do whatever you want. Inside PostNet here, you can specify whether you're expecting a multi-pose or a single pose. I left it at multi-pose, but it's up to you. You can tweak all of the different parameters inside Runway. There's no API for messing with them from the Socket.io or OSC interface, as far as I can tell. But the data is streaming, and you can see that I have X and Y. There is another transport mode for PostNet specifically, which is just raw PostNet data, which will flatten the X and Y so that you can have a single column per person, which might be easier for you to work with depending on your how you're used to working with DATs and chops, and that will give you one column per person, XY, XY, XY. If you switch it back to PostNet coordinates, you'll get XY per person. So that's 2 columns per person identified. In this case, you can see that I used a select DAT to split the data coming in for face landmarks and body landmarks, and I converted these into basically X and Y chops that I can later use for instancing. I'm instancing 2 sets of rings of donuts in different colors and sizes to match the body. Notice that it's flipped. Almost all of the Runway models, I don't know why that happens. I think it has to do with how the inference runs on the GPU, that the image gets flipped. So use the flip top. Instead of flipping the data using the math chop, in this case, because I'm rendering, it's much easier to flip the image. So I didn't want to have to do it for you. And you can see that I have these blue donuts on my face, and I have these red donuts on my shoulders. And if I go back, I should have donuts for hands. Yeah, and you can see it's really slow, but again, try this on your computer without screen recording running and maybe a slightly newer MacBook, and you should have more luck than me. But that is, oh, sorry, this camera. All right, let's see. Yeah. Hands and yeah, shoulders, and it will do full body. So it will also detect knees and feet, and as I mentioned, more than one person. So this is how you work with PoseNet. Let me stop the model here and we can move on. The next one is face landmarks. Face landmarks is very similar to David Brown's implementation, which probably works much better. But again, this is meant for experimentation. So it's these very recognizable by now denser facial landmarks. And it's the same process. You run the model. Let's try to run this one over. I'll stick to Socket.io, but OSC works in exactly the same way. You can see that I'll connect this one here because it's a different subnetwork. I'll disconnect PoseNet because the data will change. And you can see that the model is running and we're not getting any data. So as I mentioned, you need to press connect every time you start a new model. I'll press connect. Connect again. Might have to turn it on and off. Ooh, why is it complaining? Errors inside network. Let's see. Oh, sorry. Yeah, okay. This is important. I forgot myself. You need to change the model to match the model you're expecting. So face landmarks, and now we're getting these running. So face landmarks will give you all of the labels for the landmarks on the face and only a single person. So you get the labels here because it's easier to match. I tried to keep the Python code inside TouchDesigner to run as fast as I can, just because the process is already pretty slow. So we have X and Y, and it's a very similar process to instancing this as it is with PoseNet. So it matches it converts everything to a chop, uses that on an instancing of a geometry. If you're curious how it matches the images exactly, it's because it's using an orthogonal camera. And we can see the camera here. So the camera is orthogonal. The ortho width is set to the ratio of the original image, the webcam. I'm actually fitting it to the size that's used in Runway, which is 600 by 400, which you can see here. 600 by 400, because that will be what the image is cropped to or squashed to before inference, so that will be a more accurate way to place the labels afterwards. And we will go into landmarks here, and I should have blue dots all over my face. So again, you can see it's pretty slow, but it's quite accurate, and as you can see from my video, at least this stopped running well. It's not the TouchDesigner part that's slow, it's just Runway being slow. There's nothing much you can do about it, but maybe the remote models will give you better results. So you can see I can move around and I get these face landmarks everywhere. So it's quite easy to go from the output from TD-Runway onto instancing. All right, so this is face landmarks. The last 3 models that are supported, and I'll only go through one because they give exactly the same output, are DenseCap, which is pretty cool. So let me just stop the model here. DenseCap, which gives you very rich captions. For example, for me here, it says a silver can, a black and white dog, a bottle of I don't know what that even means, a man wearing a black shirt. Okay, so this is accurate for once. Or the window is blue. So it gives you a lot more detail around what is actually in the scene rather than just labeling. If this is in some kind of like more type-based interactive installation, maybe this could be cool, or some kind of motion video. But that's what DenseCap does. Coco SSD and Yolo v4 will basically just give you labels. Person, chair, very basic, but I'm normalizing the output so that they all will give you exactly the same format. So if we go to, I'll plug this in to classifiers and disconnect this here. And I'll remember to switch model this time. Let's use Yolo v4. you'll see that all of them have exactly the same data. There's a label, a score, and a bounding box with 4 coordinates. The bounding box is always from top left to bottom right. You can see this little chain of math operators to calculate the centroid. This will give you the centroid, so it's both coordinates divided by 2 will give you the centroid, and the further away coordinate minus the top coordinate will give you the width and height, which is enough to have an XY width height for instancing of geometry. But that's just the math behind calculating the bounding box into instancing. So I'll go here again, Yolo v4. First you start the model, then you press connect. All right, so we're starting. We'll wait for this. This is running remotely on the cloud GPU. So it should be less taxing on your computer. It's basically just streaming images one after another, but you can see that there's a delay. So it's basically whenever you see this flashing, it's one frame being received. But again, at least your FPS locally will be a little bit better. And we'll go back here. Again, no data, so you need to press connect. I might have to fix this connect, so we'll just activate on and off. And you can see it's finding a chair and a person. So it will give you, again, the labels. In this case, also the score. Not all of the models will have a score. I think DenseCap doesn't have a score. If there is a score, it will be there, so you can use it to filter. If there isn't score, you'll just have label and bounding boxes. So I'm converting it to chops, doing the small calculations to find the centroid and width and height, because the grid is scaled from the center. And I'm rendering them using a line material, using an instanced grid that's inside the geometry. So you can see it here. Again, flipping almost on all of, I think on all of them you'll need flipping. So it's finding a chair, it's finding me as a person. I didn't bother with instancing the text because that's a little bit of a pain in the ass. But I can put my phone here and it will find a phone. You can't really see that it's a phone, but you can see that at least the objects are well marked. And we have a bottle, and maybe let's see a glass jar if it will manage. Yeah, so the labels are there. I just didn't do anything with them because that will be more of a copy sop, and I didn't want to deal with it. But the labels are here. Chair, person, potted plant. I'll raise the bottle again, and we will probably see a bottle. Let's see what this glass jar is. Maybe it identifies as a nothing. Cup. All right. So this is how you work with all of the different kinds of classifiers. If you have specific classifiers that are on Runway and you want to add them, then I'll just quickly go through the guts of this so that you can expand them. The base model behind the approach was to build these as extendable parsers. So the face landmarks is a parser. It's a little bit of code that receives the data in a table and appends data to the table. So each of these is its own parser. If you feel like messing with this or parsing to a different format or extending another model, this is where they all live. I can also try and extend other modules that are not supported right now, but these are the main use cases. Yeah, and that is TD-Runway. So again, you can download it here on TD-Runway on GitHub. Feel free to open an issue or leave some comments if you're having trouble working with this. The final point I wanted to make was around working with video on both TouchDesigner and Inference. Thankfully, on macOS, you can use the same webcam on Runway and TouchDesigner at the same time. That's not the case with Windows. It will just not open because the device is opened exclusively. But maybe you want to classify a top, streaming from TouchDesigner. So in that case, what you can do, and I left some links here, is either use SpoutCam if you're on Windows. I did not have luck getting SpoutCam to work inside Runway. It's just not detected. But you can try. Or use a Mac where this is pretty trivial. You can use NDI Tools, which is a really cool free package for like NDI extras. One of the things that they have is a virtual input, which is basically a virtual camera that you can stream from TouchDesigner's, not just TouchDesigner, any NDI input. It automatically detects any NDI input and it becomes a webcam. But if you use the NDI out, you can have the webcam open inside TouchDesigner and then into an NDI out, it becomes a virtual device that is then streamed to Runway. There is a bit of a lag that adds on to the already somewhat extensive Runway lag. But again, if this is just a prototype or you just want to use the same webcam, then you can easily do that. The other option for Siphon is CamTwist Siphon. It's an open source project that uses CamTwist to basically create a Quartz Composer virtual camera. So the links are here. Yeah, and if you have any questions, you can, again, open an issue or hit me up. I'll make sure to have a release of the talks only here on GitHub. And I hope you have fun messing around with Runway in TouchDesigner.